and I'm Alyssa DeJesus. We are going to discuss to you the introduction to sequences
and series. So without further ado, let's get into it. Introduction to sequences and series. Summation. Presented by Aliyah R. Fetalvero and Alyssa DeJesus.
Topic outline: learning objective, sequences, series.
Learning objectives. Find any element of a sequence given a formula for its general term. Use sigma notation and expand corresponding series. Distinguish between a sequence and a series. Calculate the end partial sum of sequence.
Sequence. A sequence is a function whose domain is a set of consecutive natural number, beginning with 1. For example, the following equation with domain 1, 2, 3, and so on. 1, 2, 3, and so on defines an infinite sequence. Now, our example, given the sequence described by b of n is equal to 2n minus 4, find the 8th term and 10th term. So, sulat natin yung ito. Then, copy natin yung 2n minus 4. Ganon din dito sa 10th term. So, 2 times 8 minus 4. 2 times 8 is equal to 16. Minus 4 is equal to 12. Then, so ngayon, proceed tayo sa example number 2. 2 times 10 minus 4. 2 times 10 is equal to 20 minus 4. 20 minus 4 is equal to 16. So, this will be our 8 terms and 16 will be our 10 term. So, that is our sequence.
Series. A series is the sum of the terms of a sequence. The sum of the terms of an infinite sequence results in an infinite series, denoted as infinite. The sum of the first n terms in a sequence is called a partial sum, denoted as n. For example, given the sequence of positive odd integers 1, 3, 5. The symbol uppercase Greek letter sigma is used to indicate a series. The expression above and below indicate the range of index of summation, in this case represented by n. The lower number indicates the starting integer and the upper value indicates the ending integer. The end partial sum Sn can be expressed using sigma notation as follows. What is series? By definition, series is a sum of a sequence of terms denoted by S sub n. Let's say the Sn that will be a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 and so on. Let's say we have the sequence 3, 6, 9, 12, and 15. What would be the sum of our sequence? So to get the S sub 5, why S sub 5? Because we have 1, 2, 3, 4, 5 terms. That means n is the number of terms that you're going to sum up. So 3 plus 3, that is 9, plus 9, 18, plus 12, 30, plus 15 is equals to 45. So our S sub 5 is 45. Again, a series is simply a sum of our sequence. Let's have more exercises about series. Let's have our example number 1. Find the sum of the first 8 terms in the sequence an is equals to 1, 4, 9, 16, 25, and so on. So we're going to find a sub 8. But first, let us study our pattern. 1, 4, 9, 16, 25. What are those numbers? Those are perfect square numbers. So after 35, we have 36. After 36, we have 7 times 7, that is 49. Next will be 8 times 8, which is 64. Is our 8 terms now complete? So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to add those 8 numbers. So 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64. Now let us add. 1 plus 9, that will be 10. 4 plus 16, that will be 20. 36 plus 64, that will be 100. And 25 plus 49, that will be 74. To sum it all up, it will be 204. That is our final answer. Now let's move on to our second example. Find the sum of the first three terms of sequence defined by an is equals to 3n squared minus 1. First three terms, that is a sub 1, a sub 2, and a sub 3. So let us write the a sub 1, then copy 3n squared minus 1. With the same of this one also, 3n squared minus 1, and a sub 3 is equals to 3n squared minus 1. Now let us substitute. 3 times 1 squared minus 1. 1 squared is equals to 1 minus 1. 3 times 1 is equals to 1. 3 minus 1 is equals to 2. So 3 times 2 squared is equals to 4 minus 1. 3 times 4 is equals to 12 minus 1 is equals to 11. 3 times 3 squared minus 1. 3 squared is equals to 9 minus 1. 3 times 9 is equals to 27 minus 1 is equals to 26. So our S sub 3 is equals to 2 plus 11 plus 26 is equals to 39. So the sum of the first three terms is 39. So that is series.